Today we can see the quantitative aspects of chemical equations, or it is known as the stoichiometry. What is stoichiometry? In a balanced chemical equation, you are familiar with the chemical equation. In a balanced chemical equations, you can see the number of different reactants, isn't it? For example, 2H2 plus O2 gives 2H2. That 2 represent a stoichiometry, means 2 molecules of H2 react with 1 molecule of oxygen to give 2 molecules of H2. And the formula H2O, if you take, there you can see a stoichiometry. 2 hydrogen atoms combine with 1 oxygen. That is stoichiometry. And based on this stoichiometry, we can do several calculations. So the chemical equations are very important. For example, we can analyze a balanced chemical equation. It will give you a lot of information. The equation is CH4 plus 2O2 gives CO2 plus 2H2O. Can you tell what are the informations that we can draw from this equation? CH4, you know, what is it? Methane, O2, oxygen, CO2, carbon dioxide, H2O, water. We can say methane reacts with oxygen to form carbon dioxide and water. Or we can say 1 mole of CH4 react with the 2 moles of oxygen to give 1 mole of CO2 and 2 moles of H2O. Or we can say CH4, 12 plus 4, 16 grams CH4 react with 16 gram methane react with oxygen, molecular mass 32 into 2, 64 grams of oxygen to give carbon dioxide. What is the mass? 44 gram. 44 gram carbon dioxide and 18 into 36 gram H2O. Isn't it? So in this way, we will get a number of informations. You can try 1 or 2. Okay, you see some of the informations taken from the equation. 1 mole of CH4 react with 2 moles of O2 to give 1 mole of CO2 and 2 moles of H2O. 1 molecule of CH4 react with 2 molecules of O2 to give 1 molecule of CO2 and 2 molecules of H2O. 22.7 liters of CH4 at STP reacts with the 45.4 liters of oxygen to give 22.7 liters of CO2 and 45.4 liters of H2O gas at STP. 16 grams of CH4 react with the 2 into 32 grams of oxygen to give 44 grams of CO2 and 2 into 18 grams of H2O. All these are informations taken from this equation. This simple equation tells a lot of things to you. And our calculations, now we are going to do some calculations based on these informations. That is stoichiometric calculation. Now, if you want to solve numerical problems based on the chemical equations, the first thing that should be a balanced chemical equation. And to balance chemical equations, usually we are using trial and error method. And in the case of complex reactions, there are certain steps to balance the chemical equations. Here we are not going to discuss such steps. Here you can use trial and error method to balance chemical equation. Okay, here you can see one equation. KClO3 gives KCl plus O2. What is trial and error method? Here KCl is balanced, one potassium, one chlorine. But there are 3 oxygen atoms, only 2 oxygen atoms. To balance it, we cannot change the number of O2 here to 3. Then what we can do? We can multiply the 2 sides with a common number. We multiply the 2 sides with the certain numbers to get 6 oxygen atoms, isn't it? For example, left side you multiply with the 2. 2 KClO3 means 2 potassium, 2 Cl and 6 oxygen. And this side, if there are 2 KCl, here also 2 KCl will be there in the right side. 2 KCl. And here 2 into 3, 6 oxygen. So we can write 3O2. Now the equation is balanced. In that way, you can balance all these equations. That is trial and error method. Try left and right, change the numbers and balance. That is trial and error method. Here you can see 4 equations. You try to balance it, these 4 equations. C2H4 plus O2 gives CO2 plus H2O. There are 2 carbon atoms, so on the right side, here also there should be 2 carbon, 2 CO2. 4 hydrogen, only 2 hydrogen, so you have to write 2 H2O. Then you check whether it is balanced or not. No, the oxygen, the number of oxygen may not be balanced. How many is required? Find out and write. CaC2 plus H2O gives CaOH twice plus C2H2. Here 1 calcium, that is balanced. 2 carbon, that also balanced. 2 H2, 2 plus 2, 4 H2 is there. Here 1 oxygen, here 2 oxygen. So it is very simple. 2 H2 will give you the balanced equation. N2O5 gives NO2 plus O2. 2 nitrogen but only 1 nitrogen. 5 oxygen but only 4 oxygen. So you have to multiply with the suitable numbers to get the balanced chemical equation. You try with the 2 first. 2 N2O5 gives 2 into 2, 4. 4 NO2 plus O2. Then count the number of nitrogen atoms on the left side and right side. Count the number of oxygen atoms in the left side and right side and check whether it is balanced. You can see the answers one by one. This is the balanced equation of decomposition of KClO3. Combustion, burning of C2H4, ethene in oxygen, balanced equation. Hydrolysis of calcium carbide, balanced chemical equation. Decomposition of N2O5, balanced chemical equation. You try more equations, then it will be clear to you, the balancing of chemical equations. Now, problems based on the stoichiometry or stoichiometric calculation. Calculate the amount of water produced by the combustion of 16 grams of methane. To solve such problems, first what we have to do, write chemical equation and balance it. Here you are familiar with this equation, the previous equation, combustion of methane in oxygen. It is the equation CH4 plus 2O2 gives CO2 plus 2H2. Is it balanced? Yes, it is balanced. Balanced chemical equation. Now you write which are the compounds given here, methane and water. Methane and water. You can see methane and water. It is methane and it is H2O. In this chemical equation, first you have to write what is the mass of CH4? 16 gram, 12 plus 4, 12 gram carbon, 12 gram carbon plus 4 gram hydrogen, 12 plus 4, 16 gram. It is the mass of 1 mole of methane. 1 mole of methane. And now we can concentrate here, that is H2O. How many grams of H2O formed? 18 is the mass of one H2O. So 2 into H2O, 2 into 18, that is equal to 36 grams. This is the information that we are getting from this balanced equation. And based on this, we can write down the answer. From the equation, it is very clear what amount of water produced from 16 gram of methane is equal to 2 into 18. That is equal to 36 grams. Very simple calculation. Okay, we can try another. When you see the question, you may think that it is not possible to solve it. But read carefully. It is a very simple numerical problem. Okay, chlorine is prepared in the laboratory by treating manganese dioxide with aqueous hydrochloric acid. According to the reaction, 4HCl plus MnO2 gives 2H2O plus MnCl2 plus Cl2. How many grams of HCl react with the 5 gram of manganese dioxide? Here we can see an equation is given. The balanced equation is given in the question itself. You have to check whether it is balanced. Listen, 4 hydrogen here. How many hydrogen? 4 hydrogen. How many chlorine? 4 chlorine. 2 plus 2, 4 chlorine here. 1 manganese, 1 manganese. 2 oxygen, 2 oxygen. It is balanced. Balanced equation is given in the question itself. So that part is over. Now what is next? You have to identify the compounds given in the question, HCl and manganese dioxide. You can see manganese dioxide here, HCl. How many grams of HCl present? HCl, you know the molecular mass. H1, chlorine 35.5. So 1 plus 35.5, 36.5 into 4. 36.5 into 4. That is equal to 146 grams. So 146 gram HCl, that is reacting with the how many grams of manganese? Manganese 55 gram, and oxygen 16 plus 16, 32, 55 plus 32, manganese dioxide. What is the mass? 87 gram. Isn't it? This is the required data from the equation. And based on this data, we can solve the problem from the equation. What will you get? Mass of HCl, which is reacting with 87 grams of manganese dioxide, 146 gram. So what is the mass of HCl, which is reacting with 1 gram of manganese dioxide? All of you know this calculation, 146 divided by 87. Then you will get mass of HCl for 1 gram MnO2, isn't it? If you know the mass of HCl for 1 gram MnO2, then what is the mass for 5 gram MnO2? Mass for 1 gram into 5. That is 146 divided by 87 into 5. What is the answer? 8.39 gram. Is it clear? Now you can solve some examples here. Homework for you. Calculate the mass of iron which will be converted into its oxide, Fe3O4, by the action of 18 gram of steam on it. So iron, you know the molecular formula, Fe, steam, H2O. Fe plus H2O gives Fe3O4. That equation is not balanced. If you write it as Fe plus H2O gives Fe3O4, hydrogen, there is no hydrogen, isn't it? The right side you have to write H2O, then only the equation will be complete. So what is the skeleton of the equation? Fe plus H2O gives Fe3O4 plus H2. Then you have to balance the equation. Here you can see Fe3. So left side you have to write 3Fe. So if I tell it completely, there will be nothing for you. So you try to balance it. I told you the equation, try to balance it. We have to find out mass of iron. by the action of 18 gram H2O. So you have to concentrate on mass of iron and H2O. And from that data, you can calculate the mass. I'm giving you the answer. That is 42 gram. If you are getting 42 gram, your answer is correct. Otherwise, you have to try it again and find out the correct answer. Calculate volume of CO2 at STP obtained by treating 10 gram of pure marble with dilute HCl. So here, reactant, which are the reactant? Pure marble and dilute HCl. What is marble? CaCO3 plus HCl gives CO2. One product is given. What will be the other product? CaCO3 and HCl. So surely CaCl2 will be one of the products and H2O. So CaCl2 plus H2O plus CO2 is the product. Here you have to calculate volume of CO2 produced from 10 gram of pure marble. At STP, 1 mole CO2 means 22.4 liters. That you have to use here. So here we have to concentrate on, after balancing the equation, we have to concentrate on quantity of CO2 and CaCO3. Below CaCO3, you have to calculate its mass and write it. CaCO3, I think you know it. And below CO2, you write its volume. In the equation, if it is 1 mole CO2, write 22.4. If it is 2 mole CO2, write 2 into 22.4. Then find out the answer as we explained in the previous examples. We'll give you the answer, and if you are getting the answer, 2240 ml or 2.24 liter. 2.24 liter or 2240 ml is the answer. Try to get the answer. And the third one, what volume of oxygen at STP required for the complete combustion of 200 centimeter cube of acetylene, and what would be the volume of CO2 formed? Acetylene C2H2, that is acetylene. Here also the equation is not given. You have to write the equation. What volume of oxygen at STP required? So one of the reactant is oxygen. For the complete combustion of 200 centimeter cube of acetylene, another reactant acetylene, C2H2. Products are not mentioned. Yes, one of the products, CO2 is mentioned. CO2. So C2H2 plus O2 gives CO2 plus what will be the other product? Hydrogen is not there. So H2O will be the product. That is the skeleton of the equation. You have to balance it. Then here you can see two questions are there. First, you have to find out the volume of oxygen at STP required for 200 centimeter cube of acetylene. And in the second question, you have to find out the volume of CO2 formed at STP. So two steps are there. In the first step, what is the volume of oxygen at STP? You write the equation. C2H2 plus O2 gives CO2 plus H2O. Then you have to concentrate on the volumes of oxygen and C2H2. For 1 mole oxygen, what you can write? 22,400 ml. It is 2 mole, 2 into 22,400 ml. For 1 mole acetylene, you can write 22.4, sorry, 22,400 ml. I will give you the volume of oxygen, the other one, volume of CO2 you have to find out. Volume of oxygen, 500 centimeter cube at STP. Do it several times and find out the answer. And the last one is left for you. You find out the correct volume. Okay, you try to solve many problems from the textbook and be thorough with these portions. We can stop.